Hi, everybody, and welcome to our webinar on 5 things every new ClickHouse user should know. We're going to be focusing today on administration. In the webinar last month, we talked about development. So just a little bit of housekeeping before we get too far into this. This is being recorded, as you probably just heard. We will send you a link to the recording and the slides within a few hours of the end of the webinar. Also, we have time and ability to take questions, lots of them. My colleague, Tatiana Saltykova, is also here on the talk with me. She was responsible for many of the slides and also teaches our class on administration and runs production ClickHouse clusters. So she is an authority on everything we're going to be discussing today. And so feel free to throw your questions into the question and answer box or into the webinar chat. We'll get to as many of them as we can, maybe even go a few minutes over if we have to. My background, I am Robert Hodges, so I'm Altinity's CEO. I have been working with ClickHouse since the beginning of 2019, specifically January 1st, and it's my favorite database, as I think is probably the case for Tatiana as well. So let's dive in. That's the housekeeping done. A little bit more housekeeping. Who are we, Altinity? We are a vendor for ClickHouse. We have 2 main products or offerings. The first, which is what we began with back in 2017, is enterprise support. So we offer 24/7 support for people who like to run ClickHouse by themselves. That's about half our customers. The other half of the customers run in Altinity.cloud, and that is a cloud service that runs ClickHouse for you, either in our account or in your account. We are not the same as ClickHouse.com. People sometimes get confused. We are, in fact, competitors, although we, of course, collaborate on making the code better. So anyway, that's it for the marketing part. Let's dive in and have some fun with ClickHouse. So just going to check here really quickly to see. All right, I have a colleague who's will be joining us as well. Let's dive in. All right, so here's my AI generated lounge lizard who's been living under a rock. He's wondering what a ClickHouse is. Probably 98% of you already know this, but if you don't, ClickHouse is a real-time analytic database. You can think of it as combining the best features of a database like MySQL, being able to talk SQL, run anywhere, be open source, and with analytic databases, which are typically characterized by things like shared nothing architecture. Vertica is an example of one of the originals creators of that, storing data in columns, parallel and vectorized execution, and the ability to scale to many, many petabytes. We have customers that we help who are ingesting up to 20 petabytes a day into ClickHouse, which is a lot of data. It's super popular. So we won't be talking more about the things that make it popular, but we'll be focusing on the things that you need to do to run it and make it work well for your users. So I'm going to cover 5 things in this talk. They are chosen somewhat at random, so you may have other questions. Feel free to throw them in. The first thing I'm going to start on is the environment. So you want to pick one, and whatever you pick, it's really important to understand the ins and outs. ClickHouse can literally run anywhere. There was a blog article a few years back about running ClickHouse on a mobile phone. I don't think you'd want to do that for production, but it's possible to do it. But wherever you choose to run it, you should understand the environment well. It is very popular for people who build SaaS or sort of large scale environments to run things on Kubernetes. So we'll talk about that a little bit first. And there's a standard way that you deploy. You're going to typically run you can run it on-prem, but I think most people run in cloud these days on a managed Kubernetes service like Amazon EKS. You will have on top of, sort of running in Kubernetes itself, you'll have some base services such as Prometheus and Grafana to help do your monitoring or observability, and the ClickHouse operator to manage ClickHouse itself. And then you'll have your ClickHouse processes and Keeper, which we'll talk about in a little bit. It's necessary to coordinate replication. And you will manage the software using things like Terraform. That's typically used to set up the cloud environment. It's very popular. We use it. Or and once you're in Kubernetes, you'll use things like just running manifests or Helm or other tools, like some people use Argo CD. So if you're going to run it this way, and it's important to note that Kubernetes is not the only way to do it, it's become very popular. But if you do choose to go this way, what you'll want to do is use the ClickHouse operator. So, and what you're going to, but before you can do that, you'll need to bring up your Kubernetes. If you're using EKS, we have Terraform blueprints that will help you do that, and they make it very easy. I use this all the time when I'm using EKS. Uh, there are also you can also, of course, use GKE. You can use other things like Azure. For that, we don't have such well-developed templates. But once you bring it up, and you can see it's really just not very many commands. It takes about 20 minutes for the cluster to come up in EKS. You then go get your kubeconfig, and you can go ahead and start to connect to the server. The blueprint that we provide in open source will optionally set up ClickHouse itself and as well as the operator. So it's kind of like everything, sort of batteries included. What most people do is they take these examples and then they tweak them to their own to suit their own tastes. A little bit about the operators. So if you are running in Kubernetes, it's really important to use an operator. It really simplifies the operation of systems, particularly if you're running multiple clusters. Operators in a nutshell allow you to extend Kubernetes by defining new kinds of resources. Okay, some questions coming up. Let me just jump in. Are you free to stop? Are we free to start dropping questions in the Q&A box just now? Yes, go ahead. Drop your questions in. Tatiana can help answer some of them in the background, and you'll we'll probably get to some of them at the end as well. So and great, and we already have some questions answered in the background. So back to operators. So operators allow you to define new resources in Kubernetes to extend it, and then the operator is a controller, a special kind of controller that manages that resource. And for example, when you, in the case of ClickHouse, there's a resource called the ClickHouse installation. If you want to change the number of replicas, for example, you can just change the number, and it does it for you in a safe way that observes best practices. Now, to make operators work efficiently, you're going to have to understand how the operators go about allocating resources. And people say that Kubernetes is complicated. In the case of developers, this is, I think, not true. Applications are complicated, and the model that we use to deploy in Kubernetes just reflects that complexity. So it's not really that difficult to understand. Where it is complicated, and where you as an administrator really need to stretch yourself, is you need to understand how Kubernetes allocates resources, particularly compute and storage in the background. I won't go into the details of this, but if you're running ClickHouse by yourself, you definitely want to understand things like cluster autoscalers. You want to understand CSI drivers, which help you allocate storage. And one of the things that binds that's common across all of these mechanisms, including network integration, is you have to understand the underlying permissions model. So because EKS is going to allocate things, and it needs to have suitable roles to in IAM to do that. That's all I'll say. This gives you a sense of some of the pieces you'll need to look at. There's abundant documentation on how to do this. Why do we use operators? Well, I already mentioned it, but in case it's not obvious, they make these complex systems like ClickHouse simple. This shows you normally have about, for basic ClickHouse installation, you can describe it in 6 to 10 inches of YAML. And for example, if you want to change the version of ClickHouse that you're running, all you would do is there's this image property. You would just go change it to another container image name, and the operator will take care of upgrading or downgrading ClickHouse to use that version. There's many other things you can do. You can change the number of replicas, number of shards, amount of storage. All of these things can be controlled with very, very simple changes. So that's not the only way to run it. If you, many people run ClickHouse directly on their own hosts, whether it be racked hardware, that's pretty common for financial services and other folks who, who have a high performance computing center, or you can run it on VMs that you allocate directly in a cloud. So there are lots of, you can go to the documentation, you can deploy on ARM, you can deploy on Intel, AMD, PowerPC. I don't know too many people running PowerPC, but the images are easy to get. So this link here, when you get the slides, gives you the link in clickhouse.com. The Altinity stable builds, which we will talk about when we get around to upgrade, they are located at builds.altinity.cloud. So all of the software is very easy to get to, and you can just install it using the normal mechanisms of, for example, I usually use apt because I run Ubuntu. Now, if you're running this, you will need to understand exactly what that process is looking like on the host. So, for example, there are different ports. These are all by convention. There are the packages that are used for ClickHouse are we'll use the standard directory structure. So there's in Etsy, we have a configuration of the server. Varlib ClickHouse is where your data lives. Varlog ClickHouse is where your logs live. This is all pretty standard stuff for Linux packages. But you'll need to, one of the things I don't recommend doing, although people do it, is you can get the binaries and set these up yourselves. But I really recommend using the packaging. Using the packages if you can, because they do it right. And moreover, when it comes time to upgrade, they will do the right thing when it comes to replacing configuration files. And in fact, this brings a really important point. If you're running this yourself, you really need to understand how configuration files work. There's two main types of configuration files. Config.xml is properties that control the server operation, everything from ports to be open, to which system tables are enabled, and there's users.xml, which is where you set up your baked-in users for ClickHouse. In general, when you're creating accounts for ClickHouse, you use SQL commands to do this. We call this role-based access control. But the default user, sort of, if you will, the root user and any other users that just need to come up and be baked in, you'll define them in users.xml. It's really important not to modify these files directly. Instead, what you do is you can add your own changes to these files to config.d. They get applied to the base server, or users.d, which is where you can define users and have those changes applied to users.xml. And there's a link or a path given down here. If you want to see what the result is, in case you botched it, you can actually go and see the fully processed version to understand, for example, why something you put in just broke ClickHouse. You can, of course, run in clouds. And nowadays, a very large number of people, I wouldn't say the majority necessarily, but a very large number of people who run ClickHouse run in one of two clouds, ClickHouse Cloud or Altinity Cloud. These have trade-offs and between the different clouds, but I think the big trade-off to understand is that clouds in general trade convenience for cost and performance. And I'm not saying necessarily that clouds are more costly than running it yourself when you think about the total costs. In fact, they can be way cheaper because you don't have to hire a bunch of people to take care of the care and feeding of ClickHouse. But if you are operating at scale and you have the data center expertise, for example, you can run ClickHouse more cheaply, particularly if you have stable workloads. And you can also make it run extremely fast just by buying the right sort of hardware. ClickHouse runs great on hardware with, you say, 126 cores or 128 cores and 256 gigs of RAM. you can make it really scream. So these are things that you'll need to think about. There is no right answer on this. It's just like, what does your business need? Okay, so let's, I've got one, I'm going to make one quick administrative change. Josh Lee, you are now promoted to a panelist. So you should be joining us. Welcome, Josh. Josh is our developer advocate. He's been out there in the audience answering questions, but he does regular talks on ClickHouse as well. All right, this is it for understanding production environments. Happy to take more questions, but now I'm going to go to the next topic, which is a really important one, understanding replication and how to manage it. This is a huge topic, and I'm just going to touch it, but it'll give you a sense of how ClickHouse works in the class, and what you need to learn in order to manage it well. So ClickHouse, when it was originally developed, had what's called a shared nothing architecture, where you had a bunch of ClickHouse servers connected over a network, and each with a patch of storage that they owned. And very quickly, in fact, from I think almost very early on in the history of ClickHouse, when it was still running as a closed source system, it introduced replication and sharding. And the idea here is that if you have shards, what you're doing is taking your data set for a very large table, for example, and you're breaking it up and you're storing chunks of it on different servers. You can think of these as, we would say, these are disjoint collections of data. And when you run a query over a sharded table, you'll need to send a subquery to each of the shards, collect all the results from that shard, and then put them all back together and hand them to the user. So shards allow you to increase IOPS. So you can insert faster because you have effectively more servers available to handle the inserts. You can query more effectively, and because it's also, again, splitting up the work. Replicas help with concurrency specifically for queries, and they help for high availability. So if you lose a copy of the data, no problem. If you have 3 replicas, you'll still have 2 that can take care of it. So this is a very important feature of ClickHouse. And if you're running open source ClickHouse, you'll want to know how it works. So there's a number of sharding and replication patterns that you use. For example, the one on the right is the most common way that we organize large tables. We will have shards, which split the large table into pieces that fit on individual servers, and then each of those shards will have 2 or more replicas. That's a standard, and we call that sharded and replicated. So another way, though, that we can do replication is we can have that same cluster and have all of the tables, single copies of the tables replicated. Why would you want to do that? Well, a good example is if you have reference data that you join on, like the names of your business units or something like that. You would just have one little table, and you would replicate it to every single cluster, or every single server. And then finally, you have what's called the all sharded pattern. And what we're saying there is every server has its own copy of the data, but when we do queries, we want to see all of the copies of the data from the same table across the entire cluster. Why would you do that? Well, the best example is system tables. So a system table, and we'll talk about those more, but this allows you to define things in a way that you can do a query across all of the servers and get answers about, for example, what are current processes doing. So when you define a replicated table, you're going to use an engine called replicated merge tree. There's some variants to this for storing aggregates, but in general, you'll say something like create table name, and you'll give the engine. This is a standard way that you create a ClickHouse table, and then you'll add a path. Now, it is also possible to do this where you leave this empty, and ClickHouse will sort of figure it out for you. But in the sort of classical way that we define it, we have something where you can see for these different patterns, you will put a path in, and basically what will tell you, if the path is the same, all of the things are replicas. If the paths are different, they're shards. So you can see this, the shard 1 and shard 2, you can see how these paths work, and they combine the replicas and the shards into clusters. What this is doing, this path, what is actually happening? This is actually a path that's out in Zookeeper. We'll show you this in a minute. Zookeeper keeps track of who is in the cluster, what parts of the data does do each of them possess, and so they can find each other so that they can ensure the parts are properly replicated. So we talked about a cluster. What is a cluster? Well, it's just a collection of servers, which we say is a cluster. It's as simple as that. So it's defined in a configuration file that is by convention called remote servers.xml. And it just has these XML tags. We really like XML in ClickHouse. We say this is a shard. Here are the hosts, the specific hosts that are in it. It's going to be replicated automatically. That's it. So you can actually define the patterns of shards and replicas any way you want. There's nothing built into there's nothing built in here. It's just what you say it is. So how does replication actually work? Well, here are the table. Here's an example of a couple of tables and running on different servers. We're tracking the on-time table, and these are replicas. So what will happen is if somebody inserts something, and we'll show the details of this, into one of the tables, it's Zookeeper is going to track the fact that there's a new part, or one or more new parts that have been inserted into the table, and then the other servers, which are also listening on Zookeeper, will be able to see these parts arrive, and then they'll go grab them from the original server. And they use port 909, or 9009. This is an internal port that's used for moving parts around. So the Zookeeper nodes underneath are what's called an ensemble. You typically run 3 of them in a safe place where they are on their own hosts, where nobody else can interfere with them. It's very important for them to be left alone and not, be able to access storage, be able to have plenty of CPU cycles available to run. And you'll also notice that I say Zoo and in brackets because there's a replacement for Zookeeper called Keeper. We'll talk about the difference between that and Zookeeper in just a minute. Here we go. So the minute is already up. So a question that we commonly get is, what's the difference between these two things and which one should I use? The way that ClickHouse, when it originally was developed, used Zookeeper because it was available and handled this maintenance of consensus very well. Since then, starting about 5 years ago, perhaps, maybe 4, the ClickHouse team wrote a new version called Keeper, which basically implements the Zookeeper API for keeping track of this tree of information that everybody can see and operate on. But it's now written in C++ instead of Java, and it's bundled in with the ClickHouse server. Question we get is, which one should I use? Well, in a nutshell, if you're using Zookeeper now and it works, just keep it. It's probably not worth upgrading. If you're developing a new system and you can go and you get the choice, pick Keeper. Long-term Keeper is the future. Why is that? Well, so leaving aside issues with bugs, which there really isn't that much going on, but there are a really key point is that Zookeeper is now, it has very slow development. That's one issue. So if you have a bug, it may or may not be easy to get it fixed. So for example, we maintain Zookeeper, whereas we can fix ClickHouse Keeper, as can the core ClickHouse team. And now there are increasingly, or I should say slowly, there are features developing or being added to ClickHouse, like the S3Q engine, which actually depend on new features that are only in Keeper. So this is a reason why you would want to shift to Keeper, or certainly use it for new systems, because over time it will become the preferred solution. How do you configure the connection? That is another thing that goes in these XML files. This is just an example. A really key thing to note here, that this just allows ClickHouse to find it. A really key thing is that you can use the system tables. There's a table called system.zookeeper, which you will constantly refer to when you're managing Keeper or Zookeeper, just to find out if you're properly connected. You use this select, and it actually can read the paths inside Keeper. So this is a super useful thing to have. How does insert work? I kind of explained it. Here's a picture that explains it in more detail. And a part arrives. Uh, it gets registered in Zookeeper. It gets added to the storage of the server that took it. Meanwhile, uh, there are other servers listening in Zookeeper for parts. That these are tasks, and then when they see that, they'll go fetch the part and add it to their own storage. So pretty simple, and 99.8% of the time it works great. What's actually going on? Well, the idea is that one of the things we use Zookeeper for is to ensure that this operates as a sequential queue. So different tables get put in the queue. They can proceed. They can basically proceed in parallel. But it's really important that these things are ordered. So adding new parts or merging parts, these are in a queue. And one side effect of this is that if something for a particular table gets stuck in the queue, it will block everything behind it. So you'll need to, this is when you actually have to step in and find out what's happening. And the usual cure for this is just to wait. But the first thing is to find out what's wrong. So when that happens, one of the things that's really important to do is to you may need to go look at the queue. You could ask questions as simple as like how many things are in the queue, just a count, or you can go in and look for specific things that are in queued for replication so that you can understand what may be blocking the queue. So there's a table for that. The system tables are glorious in ClickHouse. It's called system.replication queue, and you can go ahead and look at the stuff that's currently active. This is a really great way of tracking what's going on. Most of the time, I see questions coming up about this. Most of the time, there's not a lot of load on your system and or you're adequately provisioned, you will not see problems. You will not have to do this. But when your system gets overloaded or when people make huge numbers of changes to things, that's when your replication queue can become quite full. So that's replication. Just a lesson to pass back, particularly to developers, is if you have replicated tables, one of the things that will get you into trouble is constantly refreshing the entire contents of the table, because and this is sort of something that you may do in other databases where you'll have like a report or some generated table, and every night you'll flash a new copy of that table out to the database. In ClickHouse, this can really kill replication, particularly if you do it for multiple tables all the time, because it just has a lot. It means there's a lot of data to replicate. Let's talk about schema change. So databases are not static. They change as people alter applications. Let's talk a little bit about how to change the schema. So in merge tree, which is the primary table engine, a merge tree and its variants like replicated merge tree or aggregating merge tree, these are what you use for production data that you're doing analytic queries on. There's a couple things that cannot be changed easily on them. First, you have the partition or partition by, which splits the table up into chunks of data that is divided by a partition key. Like in this one, we're dividing the tables up by year. Once you set that, you can't change it. If you want to change it, you need to copy the data to another table. So this is something in ClickHouse that you want to get right. And there's guidelines for this. Generally speaking, shoot for something that gives you, like 1,000 parts or something like that. It's pretty common when all else fails, just divide things up by month. For most time-oriented tables, that gives you a good start. The other thing is order by. So in analytic databases, the order of data within parts is critical. You can change it if you decide later on you need to change the order by, but you can only change it when you're adding columns, and you can only, so if you wanted to change the order by, you can do it if you're adding a column and you want to add that to the end of the ordering. But ClickHouse doesn't allow you to do things which would cause previously written parts to become invalid. So these are things you need to get right. If you need to change them, it's going to be painful. And in fact, this is one of the big pain points of managing, or one of the things that requires real effort. Um, Schema changes, though, in general, are pretty easy. If you're used to MySQL and Postgres, where tables just become unavailable when you're building indexes or doing other operations, ClickHouse is not like that. It's usually pretty good about doing online schema changes. Things like adding a column just happen almost instantly. They block so briefly that you're unlikely to notice them. Uh, so we call those lightweight schema changes. There are other types of schema changes, like changing data types, which we would say are heavyweight, because they not only change the metadata, but they'll require us to rematerialize the data, like change that if we're going from, say, like an int32 to an int16. I don't know if we can do that actually, but you would actually have to go rewrite your data to change the data type. ClickHouse does this efficiently, but if you have a big table, it's going to have to make that change across a bunch of parts. How does it do that? Well, it generates what's called a mutation. So ClickHouse has a queue for mutations, which are anything that changes the parts, and they get enqueued, and then they get into in a list of mutations, and then they get processed one after the other. And so these mutations mean that if you were doing things like, for example, deleting data or changing data types, they'll be in the mutation queue, and they'll take a while to flow through if you have a big table. Normally, again, this doesn't create a problem unless you do it a lot, and you have a very crowded replication queue, because combined with replication, this is just more stuff that needs to be replicated between servers. So having mutations and a lot of replication traffic is a recipe for maybe not having so much fun. So that's all I'll say. There is a system.mutations table that you can look at to see how your mutations are doing. Um, and that's another thing that, besides replication, that you want to keep an eye on. Upgrade. So upgrade is probably the least favorite part of a DBA's life, because it's the place where things can go really wrong. So let's talk a little bit about how we do it in ClickHouse. So ClickHouse is a big open source uh, project. It has thousands of, well, actually, in any given year, several hundred people contribute, unique GitHub users contribute merges. They all get put into the project. They appear in builds. It's changing fast, and what that means is there's actually a couple different strategies for upgrading. So every month we'll talk about this, but every month there's a new build or a new branch of ClickHouse that comes out, and then there are longer term releases, which we call LTS releases, long-term support. These come out twice a year, typically in March and August. So there's going to be one this month. So there's two philosophies for upgrading in general, kind of at opposite ends of the spectrum. One is you depend on new stuff that's appearing in ClickHouse. Let's say you're into data lakes. Most of the features in data lakes, like you want to see Amazon, you want to use Amazon Glue. That's a place where there's very active development going on. If you depend on that integration, you probably want to be running the latest version of ClickHouse. So we call that a leading edge upgrade strategy, where what you would do is, as soon as a new version comes out, or pretty soon, you would just upgrade directly to it. This gives you the benefit of getting the new features or bug fixes or additional integration that you need. But the downside is you're going to hit bugs. And every ClickHouse release, ClickHouse has an enormous API service, and it changes property. Things like settings change, API calls change in SQL. There are performance issues. There are regressions. If you go on one of the monthly releases, there's a good chance you're going to hit something sooner or later. And so in that case, you need to have automation so that you can revert back really fast. So you can think of it as a gopher kind of coming out of his hole, trying it out. And if things, if the food is good, he stays there. Otherwise, he darts back into the hole. So that's kind of the leading edge upgrade. Trailing edge, and that works well for teams that have a lot of, you know, you know, are really nimble, have a lot of a lot of automation, and can do upgrade and downgrade quickly. That's not true for a lot of production applications. You may have to schedule, for example, if you're going to upgrade, you may have to schedule time to test the application against the new version of ClickHouse. ClickHouse, one of the biggest issues is that the API changes. So things like there are new SQL calls. Sometimes aggregate functions have, have new arguments, or the arguments change. It's not predictable, because ClickHouse does prioritize things like speed over necessarily keeping the API static for all time. In that case, if you have a big application, it depends on the current SQL behavior. You're going to want to test it. And in large organizations or large applications, that may take a long time. So in that case, you're going to want to schedule time for schedule a month for testing, but that's not something you want to do very often. So in this case, what we're going to do is upgrade to LTS versions, and we're going to test the heck out of it so that we just do this once and then leave it maybe for another couple of years. Release schedule. So the ClickHouse release schedule is the LTS versions, which I mentioned appear in March and August. They get bug fixes for a year. This is maintained by Upstream, ClickHouse Incorporated. And then the monthly releases, they get bug fixes for 3 months. So if you're running 25.6, which is the June version, in September, you'll still get bug fixes backported, but nothing in October. So, and this table shows you what's what. In general, if you go on the non-LTS releases, you have to be prepared for the fact they'll go off support, and then you'll need to upgrade. Altinity does builds as well. We call them Altinity stable builds. They are based on the LTS releases. They're really designed for people who want to have that trailing edge upgrade. Few upgrades, but really sure that they're going to work. We publish those builds 3 months after the LTS appears, typically, and then we have a 3-year tail for maintenance. So this table shows how it works, and what you can see, for example, on 23.8, that's the LTS back in August of 2023. It's already off. The end of life was a year ago, whereas for the Altinity stable builds, the end of life is in 2026. These builds, by the way, are open source, just like ClickHouse is, and free to anybody. But if you want us to fix bugs, you have to have a support contract. So it works a bit like Red Hat, except that we don't restrict the access to the repo. Commands to upgrade. If you're running it yourself on EC2 or on racked hardware, here's an example of apt upgrade. So you will typically set the version, and then these are the 3 packages: client, server, and common static, that you need to upgrade. And what's cool is that there's a very common, ClickHouse has been very consistent about this for like basically almost a decade. Since it was open source, you'll do the apt install. This does not restart the ClickHouse server. That means that you are then able to choose when you want to restart it, and we'll get to that in just a minute. So, but you can install the software, and then you just restart when you want to actually cause the upgrade to happen. We have there's links here. One of the things we have at Altinity is an upgrade guide that's pretty popular. It's something you can get off our website, but it's written by Dima Bortzoff, who has done a bunch of these and is very familiar with it. As far as upgrade plans, a lot of details here, but a really key thing is testing. As I say, API changes, you can have different problems, but in large applications, API changes are one of the biggest problems that people run into. It's not a problem in the sense that it's a good thing because you're getting new features that make ClickHouse better, but it is a problem in the sense that it may break your applications. And if you really if the applications are critical to your business, it's better to know that in advance and not upgrade than to just plow through and just have stuff completely break. So, and in fact, there are cases where for upgrades, I don't mention this model in the slides, but this risk is sufficiently prominent for very large applications that upgrade at long intervals, that actually what those applications sometimes do is they will just spin up brand new servers running the new version, connect them to the old servers using replication, let the data replicate over, test the application against it, and then what they do is at some point they just switch over to a new version of the application. So particularly if you have upgrades that involve major changes to the application, this is a good way to do it. So it's another model for doing these trailing edge applications. It's very resource and labor intensive. Normally people upgrade in place. So that's your plan. And then rolling upgrades. This is an interesting topic. One of the things you can do in this even upgrade in place, you can have what are called canary updates. So you can go ahead and you can go ahead and just and update one of the servers and see how that works. Now, in general, this is possible when you're going, sort of have a short distance. If the distance between the versions is large enough, this won't work because there may be changes that cause replication not to work. So, and what you'll need to do is replicate, for example, in steps, or in very rare cases, you will need to update all nodes at once. This doesn't happen very often. I think, Tatiana, I think once every year or two, we get something like this. It's, and this is something where the release notes will let you know that this is happening.
You mean
where cases where you get, I can't think of, like we've had
checksum doesn't match
checksum
something.
changes, exactly.
Yeah.
So parts are, every part in a ClickHouse table has a checksum, and if the checksums are calculations turn out to be different in different versions for any reason, you would not be able to update. When they share this information, you would not be able to uh, have different versions
No,
connected by
it's really
replication.
if it's the checksums that we are
Yeah,
talking about, that it is not a big issue. It's only a problem while you have mixed versions in your cluster.
exactly.
So
Yeah,
they will resolve itself after the upgrade is finished.
yeah,
There are some cases when they really change the structure of like metadata stuff, and if you try to upgrade like from 2020 to 2025, you probably will not be able to do that. But
yeah,
yeah, that's very rare cases when you cannot upgrade from older
yeah.
version.
Yeah, and there's a question here which is very apropos. We're talking about rolling upgrade. How do you do an upgrade in the Kubernetes operator? Um, this is really glorious. Let me skip back to the slide because I even highlighted this because I knew this would come up. Let's go back to this nice picture of how we define things with the ClickHouse operator. See this image that we're looking at? That is a tag out in Docker Hub. And the way that you trigger an upgrade with a Kubernetes operator is you just change that image tag. And then what the operator will do is it will do a rolling upgrade. This is a big reason why you want for those of you who are Kubernetes buffs, this is a big reason why you want to use Kubernetes as opposed to, or use an operator as opposed to, say, writing your own implementation with stateful sets. And the reason is the operator knows has a built-in feature where it basically does a canary upgrade. It sees this, you submit your change. The operator says, okay, great, I see you've got a new Kubernetes version. What I'm going to do is I'm going to go ahead and I'm going to pull that container, well, sort of go to one of the servers, and I'm actually going to upgrade, specifically change the pod definition so that it has a new image. That will pull the image. And if that works, then what we're going to do is begin to go in parallel across all the shards. And in each case, as we're upgrading the replicas, we give them a chance to shut down, to drain out. We take them out of load balancer, out of the load balancer, take them, allow the, current transactions or current queries to drain out, and then we do the upgrade. So there's a bunch of and you get all of that for free just by making a one-line change in in this Docker image. This is one of the reasons, this is one of the places orchestration is what Kubernetes does great. So uh, 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 so this is one of the things that's really powerful. That said, lots of people run this, sort of on their own hosts. In that case, you will want to have something, some sort of automation to handle that, because it's not something you want to do manually. Okay, so great question. Thank you very much for that. Happy to answer more. All right, I think that was pretty much it for upgrade. Yeah, so rolling upgrades, that's definitely something you want to do. Are there any, oh yes, Kubernetes, we're on the topic. Are there any cons to using Kubernetes? Yes, it's more complicated. So the other thing about Kubernetes is, I'll give you a specific example of where Kubernetes is a little bit tricky. The Kubernetes is built on a philosophy that if things get sick, you just restart them. And the way that it determines whether something is sick is Kubernetes has something called a liveness probe, where it's checking constantly to see if a server, which is to say a pod, that's the Kubernetes resource name, if it's still responding. If it's not, after a certain period of time, Kubernetes will restart it. Well, that's great for a web server, for a website where you have a bunch of different processes handling page requests. It's not good for a server where you might have like an hour for caches to populate, or you might have to have a long, like a long period of time for it to restart, because it actually has to go through, open up all the, check all the parts, open them up, pull in indexes, all sorts of stuff like that. So if you run it on your own host, you can avoid that, because what will happen is the server will just get busy and non-responsive. But as soon as it clears out the whatever backlog was causing problems, it'll just come back and be live. In Kubernetes, it'd be restarted. So you have issues like that. The other thing about Kubernetes is, as I said, you really need to understand how it works. And the hard part in Kubernetes is understanding that underlying infrastructure that connects Kubernetes to your cloud infrastructure. If you know that, and many people today do, you'll be fine on Kubernetes. If you don't, you may find it difficult. So you either need to learn it or run it a different way. Let's talk about the last thing, system tables. I love system tables. They are one of the single best features in ClickHouse. They are the best system tables of any database I've ever used. So, and this is going to be a little bit random, but I'll just give you some hints. There's so many of them. It's really hard to provide, to go into any depth. I just want to convey the richness that's available here. First of all, you have tables that give you your basic monitoring. So asynchronous metrics, and events, you can read them off the slide here. They are, for example, like the events are just your counters. They're, like number of inserts, things like that, or number of queries. These are great because if you export them and feed them into Grafana, this allows you to get your time series, seeing like, hey, how many queries per second, things like that. Then you have the asynchronous inserts. Those are counters that are updated in background metrics, which are current values. The Kubernetes operator exports these. I don't know if it does metrics, but it does async metrics and events. These are automatically exported in so that you can scrape them into Prometheus. It uses the Prometheus export format, and that's the standard way, particularly in Kubernetes, but also outside. That's a standard way of collecting these metrics and then making them available to Grafana, which is kind of the default and the most popular way to build your monitoring dashboards. But there's a lot more. So for example, let's say that you're trying to figure out why I/O is not working for you, why things are going slowly. There's a raft of system tables that you can look at. First of all, if you think you've got I/O problems, or even before, first thing you do is go look at the tables and check things like, hey, do they have too many parts? If you have a table with 100,000 parts, that's going to be a problem almost no matter what. So you can look in system.parts and do counts of the parts by table. The system.tables and system.columns will tell you useful things like how big are the tables, what's the compression levels, particularly at the column level. That can be a clue that, hey, something is compressing poorly. Let's try to change the compression. That's something you do online. And then if you're having, and then as you move from that sort of static analysis, you can say, hey, what's going on right now? System dot processes, for example, what's running in the system now. And then finally, history. So two particularly useful ones that you almost always want to have enabled are the part log and the query log. Part log shows you the history of all the things that happen to parts. That's vital to figure things like, hey, how fast am I ingesting data into the system, and how big are the blocks? Because ClickHouse likes big blocks. Query log, what are all the queries that have been run? What exact resources did they use, and how much of them? And this is an incredibly helpful table. So one that you're going to want to sort of pull in for this type of investigation. CPU. So you're running low on CPU. Lots of things that give you a sense of what's going on. Merges are a big consumer of resources. There is a table system that merges, which tells you, hey, what merges are active right now, so that you can get a sense of if your system is slow, is that what's causing the problem? And if so, which table, for example, is causing it? And then there's history. Again, part log comes up here, query log, you'll see that again and again. Trace log, that's a very expensive one, but you can get query profiler traces is actually a really powerful feature that Josh has done talks about. There's also system tables for memory. In the interest of time, I left them out, but let me just give you a couple examples. Here's one of my favorite queries just to find out really quickly what's the level of compression on a table, so that in my case, so that I can boast about it to people who run other databases. But this is just finding at the level of the table. We're actually using system.coms and then aggregating up to the grouping by table. And then that gives me an overall summary of what's my compression ratio for each table in the current database. So very simple. If you see something you don't like, you can then you can tweak it, change the like add codex, for example, and then run this again to see what the effect is. Investigating resource heavy queries. This is a great example from one of our from Misha Filimonov. So what this is doing is trying to find query patterns that are particularly resource heavy. So this normalized query hash is a really cool feature of the query log. It basically hashes similar queries down to the same value. And then what you can do is, and then show a sample version. They'll differ by arguments. And then this profile events, I've highlighted, this is a really key field or column in the query log. It gives us events that have sort of like specific resources and how much of them did we use. In this case, like number of microseconds of execution time. And then this is using the cluster all replicas, which is basically treating every system.query log table across your entire cluster as a separate shard and running the query across all shards. So this query gives you statistics across your entire cluster, not just for a single server. So this is an example of the power that's available in these in the system, in the system tables in general, and specifically the system.query log, which should be one of your favorite tables. Here's another example pulled from query log, a little bit different. I'm looking for I have a specific query, and so it has a query ID, and this is a distributed query. It's being sent to a bunch of underlying servers in this particular case for reading data out of Parquet, and I want to find out what my S3 statistics were for this entire distributed query, not just the query that arrived on the initiator host, but all the subqueries that were generated from that. How many, basically what kind of load did they put on, or what kind of demand did they put on my S3 storage? So that's it. This has been kind of a lightning tour. It's gone pretty deep, but there's a bunch of information here, and let me just give a quick summary. So yeah, ClickHouse can run anywhere. Don't uh, uh, don't believe what other people say. Just make the choice that, I mean, they can give you advice. I can tell you, hey, I personally like Kubernetes, but you shouldn't, that opinion doesn't count for much. It's what you want to accomplish. If you're running a trading system, a good chance you don't want to run Kubernetes because you just want raw performance and you never want it to fail or never want it to go down. So run it on racked hardware. But you need to understand how it works. The second is replication is the single most powerful feature inside ClickHouse, open source ClickHouse, but you need to understand how it works. And there are things like mutations, excessive numbers of changes that can cause replication to bog down. Knowing where to look is really important. One thing I will say is that many replication problems are cured by time. You just, sort of stop doing, if you can figure out whatever it was that your application was doing that was killing it, stop doing that and then wait and it will clear up. It's very robust. Uh, ClickHouse is great for online schema changes, but if you have to materialize things, it will add load to your system and you need to be aware of that. And then there are just a couple things that, like the partition by, that you got to get them right. Otherwise, you'll have to copy the table, the data later, and that is painful. Upgrade, multiple ways to do it, but the key success factors are planning, testing, automation. This is the same as every other database ever, but the automation is particularly important because in ClickHouse, you're often running many servers. So you might have 24 servers, eight shards, three replicas. So you don't want to be doing that by hand. It's important. Um, and then system tables, I totally love them. Everybody uses them. The best thing you can do, we didn't go into this in depth, but export the values, put them into Grafana. That is having that available, or you can use Datadog, whatever you've picked. Go ahead and use that, but you want to have access to this information. It's an incredibly rich source of understanding of what ClickHouse is up to and when things are wrong, what's causing the problem. So there's lots of sources of information. I stole virtually all of these slides from uh, Tatiana's administration course. We teach a course on this. It's not an hour. It is 8 hours of glorious delving into ClickHouse administration. A bunch of sources here. From the ClickHouse docs through Altinity, through particularly blogs. The Tiny Bird blog writes rarely, but they often have really good stuff. Obviously, ClickHouse Inc. and Altinity, we write lots of things. And this is a new thing. I would say, if you're using Chrome, you're going to get AI overviews. You want to be really wary of what it's telling you, particularly if it's something related to administration. And it's not saying that it's wrong, but the problem is that there's not a lot of training data on making, sort of administering large systems. It's not like Python where, there's billions of lines of code that you can train on. This stuff is complicated. There's not a lot of training data. So if an AI tells you, hey, you don't have to worry about detached parts, um, just delete them. That's actually not the right answer. So just verify what it's telling you. And if you have any questions, you can come talk to us. So we do, as I said, we do enterprise support. We do Altinity.cloud. We have a lot of experience running these systems and helping people run. We have about 250 plus customers right now. And there's lots of ways you can contact us. The best probably is come to our Slack channel and ask us questions, and we will try to help. And finally, if you love this stuff and you think you could do it better than we did, we want to talk to you. We're looking for somebody particularly who can cover the Western United States. So if you think you are that person, check out our and send us your resume. Thank you so much. We can stick around for a couple more questions, but Tatiana, thank you so much for helping Josh. Thank you. And yeah, and good luck to everybody running your ClickHouse servers. So Tatiana, do you have any questions that you want to highlight? It sounds like I think we've got most of them covered in the background.
Yeah, there is one a question about settings. Which important server session settings should be modified?
Ooh,
I started
yeah.
to type, but it's so there is no specific one that would kind of be fitting for multi-tenant specifically. There are probably like by default, most of the settings are good to go. And usually what happens, you start with what you have, with the default ones, and then you just change them as you see how your system behaves and what it needs to, how it needs to run it. It depends on the specific use case. Mostly for multi-tenants, I don't think there is something special for that particular case.
Yeah, that's a great topic because what I would say, it's not so much settings. The thing I would point out
Exactly.
is
Mm-hmm.
it's partitioning and sorting. So in multi-tenant systems, if you come from MySQL, you think, hey, I want to have a database for every tenant, and that's the right thing to do in MySQL. In ClickHouse, it's not. In fact, it's almost always wrong. What you want to do in ClickHouse is partition by time, because that creates parts that are about the same, parts and partitions that are about the same difference, modulo growth or decrease in traffic, but then you order by tenants. So this is an example. This is a database of airline data. You can think of the carriers as your tenants. Here we have partitioned by year. So we get nice kind of even chunks of data each year. And then the carrier is the tenant. And so by ordering that, that means all the carrier data is in a contiguous section of storage. And that's a really key, very basic lesson, but something that we always recommend people do it this way unless they have substantial reason for deviating. Okay.
Yeah, and we also got a question from Silvia in the chat, how to best retrieve a lost replica, like when a host got lost.
Ah, right.
Um,
Yes.
yeah, and I don't really understand in this case if the data is lost or just so the storage is attached to is the storage also lost or not? Um,
Oh,
data
data
is
loss.
lost.
Yeah.
Well, yeah, you can just create a new replica.
Yeah. That's the simplest.
Yeah, and drop the old one. There are system drop replica commands that you can use to drop the metadata so that it doesn't get lost in Zookeeper or Keeper, and just create a new replica. Um,
Right.
Maybe that would be easier than
Yeah.
recovering.
You can, what will happen is replicas, if they don't, there's two ways you can lose data. The first is to lose the data completely, and then yeah, just blow away the replica and make a new one. And in Kubernetes, what you can now do is if you remove kill the PVC, the persistent volume request, and then go ahead and terminate the pod, what will happen is delete the pod. What will happen is it'll come back up and it will automatically repopulate the data. And because the operator sets up replication for you, it'll just happen automatically. Um, if But the other kind of way you can lose data is if replicas are offline for long enough, they will sort of get detached from their metadata in Zookeeper. In that case, you can drop the replicator and it's a system restore replica, right? And then what it does is it just reads the data back off the disk, and the replicator, the replica gets properly synced with Keeper again, and you're good. So
Yeah, you
we
can
get
do restore replica as well
yeah.
if you have
If
the
your storage is
metadata.
good, if your storage is good.
Yeah.
So that's a feature I'm proud to say that we put in Altinity. It's super. We use it all the time. Uh, Great. I think we're over time here. Thank you so much, everybody. Thanks again to Tatiana and Josh. And yeah, please do come visit us. Check us out on whatever's most convenient for you. And as I said before, good luck in running ClickHouse. It is a wonderful database, and you can build great applications. Tell your friends about it, and let us know how it worked out. Thank you very much, and have a great day.